Let's prepare datasets to join. We'll be using Airtraffic data as well as retail data while going through the tasks. We need to ensure that airport codes is in HDFS. We'll be using airport codes along with Airtraffic data for the month of January 2008 to explore tasks related to joins. When it comes to retail data, we'll be using data which is in JSON format. Make sure you also have the retail data using JSON format in appropriate location so that you can go through the tasks related to joins at a later point in time. The advantage of using JSON format is we do not have to specify the schema explicitly. It can infer the schema based upon the information we have as part of the JSON files. That being said, let's make sure that we have the Spark session object. Once the Spark session object is created, we should be able to use HDFS commands to actually validate whether the files are there in the target location or not. You can run the shell commands using Jupyter either by using exclamation mark like this or by using %% sh magic. In this case, I'm using exclamation mark approach. If you want to run these commands using terminal, you should be able to launch the terminal like this, and then you should be able to run these commands as part of the terminal. I'm copying only the command part, not the special character we have at the beginning, and then pasting it here. Then we should be able to see the files in this location. If you are using our labs, you will be having read-only access to this location. Using this location, you should be able to read the data and then process it further depending upon your requirements. This is the output that is returned here. It contains 3 records. One is airport codes, second one is air traffic, and third one is air traffic -part. This is the folder in which we have our air traffic data using Parquet file format, and also the data is partitioned by month. We have already explored air traffic part in the past, and hence I'm not going through too many details here. Let's understand a bit more details about airport codes. You can actually run HDFS DFS-ls on airport codes, and you should be able to see the details about the files in this location. There's only one file. It is nothing but airport-codes-na.txt. NA stands for North America here. It seems to be text file format. If you want to confirm, you can actually use HDFS DFS-cat on top of this file, and you should be able to see the details. Let's say HDFS DFS-cat, and then paste the path of the file and hit enter. It's a small file, and hence we should be able to use cat to preview the output. You will be seeing the output in a moment. Then you can actually go through the output. For some reason it is not printing properly. I think there is some issue with respect to my terminal here. Let's try one more time. Yeah, there is some issue. Don't worry too much about it. I have already done the analysis, and I will explain based upon my understanding. First, we have created a variable by name airport codes path using this string. This is the path in which we have the file related to airport codes. Using this path, we have created data frame by name airport codes. As this is a tab delimited text file, we are using CSV to actually read the files from this location. When it comes to the delimiter between the attributes, we have used tab character. Tab is not default with respect to CSV, comma is the default. As we are using custom delimiter, we have to use sep, and we have to set it to tab character like this. So this will take care of reading the data which is tab separated. There is a header for our data, and hence we are saying header as true, so that using header the columns will be determined. Also, we want to determine the data types based on the values we have as part of the columns in the data frame. To make sure that appropriate data frames are chosen, we can set infer schema to true. This will take care of defining the data types appropriately. These two will take care of defining the column names and the data types. Now you should be able to preview this data frame. Print schema is the one which will give us the schema details. You can see that the data frame contains 4 fields: city, state, country, and IATA. All of them are of type string. You can also preview the data in the data frame using show. You can see first 20 records as part of the output here. You can also get the count. We have only 526 airports in North America region. That's why we got 526 as output. You can also review the files in flight month equal to 2008-01 under air traffic -part. We have explored this path earlier also to perform few tasks related to basic transformations. You can see that under this location there is one Parquet file which is compressed using Snappy. We'll be using this quite extensively even as part of the joins. Now with respect to retail-db JSON, it have several subfolders. It have categories, customers, departments, order details, order items, orders, and products. Order details is a special one. Don't worry too much about this at this time, but we'll be using one or more of the other subfolders. It can be orders, order items, or even categories, customers, and departments depending upon the task we are going to perform. So this is the location for the subfolders which contain JSON files. All these files are of type JSON. Even though there is no extension, they are of type JSON. For one of the file there is extension. For most of the other files we do not have extensions. That being said, if you want to read JSON, this is how you can read. In this case, I'm reading orders data from this location into the data frame orders. You can preview the schema here. It contains 4 fields: customer ID, date, ID, and status. You can preview some of the records using show, and also you can get the count. So we'll be using either Airtraffic data in conjunction with airport codes or retail DB dataset to explore all the aspects related to joins. We'll be performing quite a few tasks so that we are comfortable with joins. Make sure you have set up the datasets before going into the details related to joins so that you can practice hands-on.